Hello there, and welcome back to the Sleep Night Space. I'm so glad you found your way here tonight. Perhaps the world felt a little too loud today. Perhaps your mind is still racing with lists, plans, and conversations that have already passed. Or maybe you are simply the kind of person who finds peace in the vastness of things, who likes falling asleep to deep thoughts and cosmic mysteries, rather than counting sheep. Whatever brought you here, know that tonight's journey is for you. You have nothing left to do, no one to answer to, no problems to solve. For the next few hours, your only task is to rest. Let your shoulders drop away from your ears. Unclench your jaw. Let your breathing slow down, deeper and slower. Feel your body grow light, as if gravity itself has softened its grip on you. Because tonight, we aren't simply stargazing from the ground. We are leaving the Earth behind. We are drifting up, past the atmosphere, past the moon, and out into the deep silence of our home galaxy. The Milky Way is a vast spiral of stars, dust, and dark matter, turning slowly in space for over 13 billion years. It is a city of light, holding over 100 billion suns, each with its own story, its own planets, its own quiet corner of the dark. But beneath its beauty lie secrets, rogue stars fleeing the core, invisible forces holding the arms together, and ancient remains that defy what we thought we knew about how galaxies are born. We will travel gently from its outer spiral arms to its secretive, hidden core, from colossal collisions that reshape the sky to stars older than the galaxy itself. You'll hear of supermassive black holes and glowing stellar nurseries, and the strange, unfinished story of a galaxy that is still growing, still eating, still evolving. Some of what you hear tonight may surprise you, or at the very least, spark a gentle curiosity that distracts you from the day, allowing you to drift off to sleep. And just before we begin, if these calm, curious explorations help you unwind or give you a quiet way to end your day, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Now let's begin. The structure, history. The Milky Way has already collided with other galaxies, and it will again. Our galaxy may feel like a stable, permanent home, but in reality, it is a composite structure built from the wreckage of others. Over billions of years, the Milky Way has absorbed smaller galaxies that drifted too close, drawing them in with its immense gravity, unraveling them strand by strand, and scattering their stars into long tidal streams that wrap around the disk like ribbons. One such galaxy, known as the Sagittarius Dwarf, is being pulled apart right now. It is looping through the Milky Way's disk, losing its stars to our halo, and far off in the night sky, a much larger neighbor is watching. The Andromeda galaxy is drifting slowly, steadily closer to us. In about 4.5 billion years, the two great spirals will meet in a cosmic collision. It sounds violent, but space is so vast that individual stars will almost never hit each other. Instead, They will pass like ghosts, while gravity warps the galaxy's shapes forever, folding them into a new form. Vast, elliptical, and quiet. Even galaxies are not eternal. They evolve, they collide, and they begin again. Some stars in the Milky Way are older than the Milky Way itself. Not every star in our sky was born here. Some halo stars, ancient, metal-poor, and wandering in long, tilted orbits, appear to have formed even before the Milky Way had fully taken shape. Astronomers believe these stars may have originated in smaller, primordial galaxies that merged with our own billions of years ago, back when the universe was densely packed. Their chemical fingerprints reveal their age. They show almost no heavy elements like iron or gold, suggesting they were born shortly after the Big Bang. From pristine hydrogen and helium, they move slowly, high above the galactic plane, far from the crowded disk, like elder spirits from a time before spirals, before order. In their faint, red light, we glimpse a universe that was younger, wilder, and still learning to become what it is today. Our solar system orbits the center of the Milky Way at over 800,000 kilometers per hour. That is a speed difficult to comprehend. It means we are moving more than 200 kilometers every single second. And still, the galaxy is so vast that it takes about 225 million years to complete just one single loop around the center. This vast path is called a galactic year. In Earth time, we have only gone around the Milky Way about 20 times since the solar system formed. When the first dinosaurs appeared on Earth, we were in a completely different part of the galaxy. On the other side of the wheel, the stars we see in the sky today weren't nearby back then, and they won't remain nearby in the future. Everything is in motion, quietly, slowly, endlessly, even as we sleep in our beds. The Earth turns, the moon circles, and the entire solar system sweeps forward through a galaxy in constant, fluid motion. The galaxy is still growing. Although the Milky Way is ancient, nearly as old as the universe, it isn't finished. Even now, it continues to gather material from the darkness around it. It pulls in fresh gas from the intergalactic medium. It captures stars from dwarf galaxies that stray too close. And it feeds on streams of dark matter that channel into its halo. It grows not like a living thing, expanding from within, but like a gravitational structure deepening over time, accumulating mass. Some of this growth happens quietly, through the gentle infall of gas clouds. Other times, it comes with disruption, as satellite galaxies are torn apart and their stars scattered across the sky. The galaxy you live in today is not the same one the dinosaurs saw, and the one your distant descendants may know could be larger still, stitched from the ruins of 1,000 smaller worlds, evolving into a grander giant. We don't know exactly how many arms the Milky Way has. It seems like a basic fact we should know. What does our home look like? How many spiral arms wind out from the center? But because we live deep inside the disk, embedded in the gas and dust, It is hard to see the whole structure. It is like trying to map a forest while standing tied to a tree in the middle of it. Dust clouds obscure distant regions. Stars blur into one another in the crowded plain. For decades, astronomers believed there were four major spiral arms: Scutum Centaurus, Perseus, Norma, and Sagittarius. But more recent observations suggest there may be fewer major arms, perhaps just two dominant ones, or that the arms twist, split, and branch in ways more complex than a simple pinwheel. Some fade into fragments, others wrap around unexpectedly. The Milky Way may not be a neat, symmetrical spiral at all, but a living, layered swirl of stars, shaped by turbulence and forces we still don't fully understand. Rogue stars are flung from the core at impossible speeds. Most stars drift calmly through the galaxy, obeying the speed limit of their orbits. But a rare few are flung outward at astonishing velocities, speeds fast enough to escape the gravitational pull of the Milky Way entirely. These are known as hypervelocity stars. They are often the remnants of binary systems that wandered too close to the center, close to the supermassive black hole. In a gravitational dance, one star falls in and is consumed or trapped. The other is slingshot outwards, stealing energy from the encounter. It is hurtled into the dark at over 2 million kilometers per hour. These rogue stars travel alone, far from the galactic plane, cutting through the halo like glowing comets with no return ticket. They remind us that even in a galaxy bound by gravity, there are moments of violent release, quiet expulsions that send stars flying into the lonely intergalactic night. The Milky Way and Andromeda are on a collision course. If you look high above the horizon on a dark night, the Andromeda galaxy appears as a faint blur, a spiral much like our own, lying over 2.5 million light years away. It looks static, but it is moving steadily toward us at 110 kilometers per second. Gravity is drawing the two giants together. In about 4.5 billion years, the Milky Way and Andromeda will collide. The event will be spectacular, but not destructive for individual worlds. Stars are spaced so far apart that they will almost never hit each other directly. Instead, they will pass like swarms of bees mixing together. But their gravity will warp both galaxies into long, stretching arcs. Tidal tails of gas and stars will curl outward into the void. The central black holes may spiral together and merge. And after billions of years of settling, the two galaxies will become a single, giant elliptical system. It will be a slow, elegant dance of unification, the future of our home, written across the stars. Some stars orbit backward. Most stars in the Milky Way orbit the center in the same general direction, carried by the rotation of the disk. But not all follow the rules. Some stars, especially those in the outer halo, move in retrograde, orbiting opposite to the galaxy's main rotation. These stars likely arrived from elsewhere. They were born in dwarf galaxies that were later absorbed and dismantled by the Milky Way. Their reversed motion is a quiet signature of their foreign origin. It's as if the galaxy carries old memories in its motion. Stories of ancient mergers and cosmic encounters, preserved not in light, but in the slow, patient turning of stars moving against the stream. The chemical makeup of stars reveals their origin. Every star carries a unique chemical fingerprint, a specific pattern of elements imprinted at birth. By studying these signatures using spectroscopy, astronomers can trace a star's history. Some stars are rich in heavy elements like iron, calcium, and oxygen. This suggests they formed in dense, metal-rich regions where many stars had lived and died before them. Others are nearly pure hydrogen and helium, ancient relics born when the universe was still young. These chemical differences allow scientists to group stars into families, to uncover ancient mergers that happened eons ago, and to reconstruct the hidden story of the Milky Way's formation. In this way, chemistry becomes a kind of time machine, letting us read a star's past like a line of ancient poetry written in light. The sky is full of stellar streams from shredded galaxies. Across the sky, thin ribbons of stars stretch in immense arcs and curves. They are barely visible to the eye, but unmistakable when mapped with precision data. These are stellar streams, the remnants of smaller galaxies or star clusters that wandered too close to the Milky Way. Caught in our gravity, they were pulled apart. As they orbit, their stars are smeared across space by tidal forces, forming long, delicate trails that trace their former paths through the halo. Some wrap around the galaxy like ghostly rings. Others dive in toward the core. These streams are physical evidence of past collisions, quiet mergers that built the Milky Way up from smaller pieces over billions of years. The galaxy, like a great tree, carries the rings of its past growth in every thread of light. The Milky Way is warped like a vinyl record left in the sun. Our galaxy doesn't lie flat like a perfect pancake or saucer. Its disk bends upward on one side and downward on the other, forming a graceful S-wave or warp across the stars. This subtle distortion was invisible to us until radio telescopes mapped the hydrogen gas that stretches far beyond the visible starlight. Astronomers believe the distortion may be caused by the gravitational tug of satellite galaxies, like the Magellanic Clouds pulling gently on the Milky Way's edges, or perhaps by clumps of dark matter bending the structure from below. Like ripples in a great spinning sheet, the warp reveals that even galaxies are never fully rigid or still. Over time, they bend, flex, and change form in response to invisible forces. From a distance, the Milky Way might look like it's dancing slowly through space. You can only see a tiny fraction of the Milky Way with the naked eye. Under a clear, dark sky, far from cities and streetlights, you might see a few thousand stars. To the human eye, that seems like an ocean of light, infinite and overwhelming. But in reality, it is barely a droplet. The Milky Way contains over 100 billion stars. Some estimates say 400 billion. Most are hidden from our view. Some lie behind thick curtains of interstellar dust that block visible light. Others are simply too faint or too far away for our vision to reach. The pale streak of the Milky Way that crosses the sky on moonless nights is just the innermost whisper of the whole structure. We live surrounded by a colossal river of starlight, and yet almost all of it remains invisible to us, too vast to grasp from within. The dynamics, physics, stars orbit the galaxy at different speeds, unlike planets in a solar system, which follow neat, predictable tracks around their star. Stars in the Milky Way move with more freedom and complexity. Some race ahead in the inner regions. Others drift slowly along the outskirts. But interestingly, the rotation doesn't slow down at the edge as much as physics predicts. This difference in speed and the way stars bunch up is why spiral arms form. They're not solid structures like the spokes of a wheel, but patterns like slow traffic jams of stars and gas moving through space. As these density waves pass, they compress the gas clouds, triggering new stars to form and lighting up the arms and curls of blue and white. Our own sun is part of this swirl, moving in and out of these spiral patterns across deep time. The galaxy is not a clock. It is a current, and we're drifting in it. The galaxy holds together because of something we cannot see. By all logic, the Milky Way should not exist. Based on what we can measure, the visible mass of stars, dust, and gas, the outer edges of the galaxy are spinning too fast. According to Newton's laws, they should be flung into space, scattered like leaves in a storm. And yet, they remain. They hold their orbits. The answer, scientists believe, is dark matter. This mysterious substance does not shine, reflect, or emit any light, but exerts gravity. And there's so much of it that it outweighs all the visible matter in the galaxy by a ratio of 5-1. We don't know what dark matter is. It passes through us without a trace. But we know that without it, the Milky Way would fly apart. It is the invisible scaffolding that holds everything in place. The silent glue of the cosmos. There's a supermassive black hole at the core, at the very center of the Milky Way. Hidden behind thick lanes of dust lies a monster, a singular point of gravity called Sagittarius A*, Sagittarius A star. It is an object more than 4 million times the mass of the Sun. Yet it occupies a space smaller than the orbit of Mercury. We cannot see the black hole directly, for it traps all light. But we've watched nearby stars whip around it at tremendous speeds, tracing invisible loops through the void, pulled by an irresistible force. Sometimes gas and dust fall inward and flare with X-rays as they spiral into the event horizon. For now, Sagittarius A* sleeps. It is a quiet nucleus, but long ago, it may have burned like a quasar, lighting up the galaxy from within. It is the silent conductor of the Milky Way's heart. pulling stars into a slow, relentless, eternal dance. The Milky Way has a peanut-shaped bulge. When astronomers mapped the center of the galaxy in 3D, they discovered something unexpected. The central bulge of stars is not a smooth, round ball or sphere. It is shaped like a giant peanut, or a boxy X shape. Seen from the side, it swells in the middle and narrows at the ends, like a twisting hourglass made of stars. This strange geometry likely formed from the galaxy's central bar, a dense stripe of stars that rotates slowly, buckling and puffing upward over time due to instability. These inner structures are sculpted by gravity, by billions of years of motion, and the accumulated rhythm of stellar orbits. We live in a spiral galaxy, but its heart is full of complexity, not flat or clean, but intricate, buckled, and alive. Stellar nurseries shape the spiral arms. The Milky Way spiral arms are not simply made of stars. They're woven from the birthplaces of stars. Giant clouds of molecular hydrogen, dust, and organic compounds drift through the galaxy. And when these clouds pass through the compression of the spiral arms, they collapse, they heat up, they ignite. They are set alight with newborn suns. These regions are called stellar nurseries. Places like the Orion Nebula or the Eagle Nebula. Chaotic, glowing, and full of motion. Ultraviolet light from massive new stars lights up the surrounding clouds, painting the arms with radiant blues, pinks, and silvers. These bursts of creation trace out the spiral shape for us to see, illuminating the curves of the galaxy with quiet fire. Every star, even the sun, was born from one of these cloudy cradles long ago. The Milky Way is surrounded by a vast halo. Beyond the flat, shining spiral disk lies something far more diffuse. A spherical halo that surrounds the entire galaxy like a shell. It contains ancient stars, globular clusters, and enormous amounts of dark matter, though it is nearly invisible to the eye. This halo may hold the majority of the Milky Way's mass. Its stars are spread thin across vast distances, orbiting in long, slow arcs that rarely touch the crowded disk. The halo also preserves the remnants of ancient galactic mergers, streams and shells of stars torn from smaller galaxies and left behind like cosmic fossils. It is the galaxy's outer memory, quiet, dim, ancient, but still in motion, still shaping what the Milky Way becomes. It contains over 150 globular clusters. Globular clusters are among the oldest objects in the galaxy. They are compact spheres made of hundreds of thousands of tightly bound stars. Gravity holds them together so tightly that in their centers, stars are packed thousands of times closer than in our neighborhood. They orbit the galactic center in the halo like moths circling a distant flame. These clusters are incredibly stable. Some are more than 12 billion years old, and many contain stars that predate the Milky Way itself. The stars within them are metal poor, meaning they formed before the universe had time to create many of the heavier elements like carbon or iron. They serve as time capsules, holding clues to how the galaxy formed, what it consumed, and what conditions were like in the early cosmos. These quiet, golden spheres drift patiently above and below the galactic plane, glowing softly in the dark. Star formation is slowing down. Long ago, the Milky Way was a firestorm of creation, bursting with fresh stars born from dense, collapsing clouds of gas. The sky would have been blazing with blue giants and supernova explosions. But in recent epochs, the pace has slowed. There is still gas available, but much of it is spread thin, heated, or locked in forms that resist collapse. The galaxy is not done making stars. About 7 new stars are born every year, but it is settling. Astronomers estimate that star formation peaked billions of years ago and has been declining ever since. This does not mean the end is near, only that we live in a quieter chapter, a mature spiral, glowing gently in its middle age, still forming stars, but no longer in a hurry. A galaxy at rest. Some stars formed before the Milky Way had a disk. The disk, the broad, flat spiral we think of as the Milky Way, formed gradually over time as gas settled. But some of the stars in our galaxy are older than the disk itself. These ancient stars reside mostly in the halo or the thick disk, and they formed when the galaxy was still assembling. A loose, chaotic cloud of stars, gas, and dark matter slowly collapsing inward. By studying their composition and motion, astronomers can peer back into the era before structure, before spirals. These stars are the elders of the galaxy, silent witnesses to its birth and the long, slow shaping of what we now call home. They remember a time when the galaxy was formless and void. The Sun has completed fewer than 25 galactic orbits. The Sun has only circled the Milky Way around 20 times in its life. That's fewer than you might expect, considering its incredible speed. But the galaxy is so vast, and the Sun's path so long, that each orbit takes hundreds of millions of years. The last time we were here, dinosaurs were just evolving. The time before that, trees were just appearing on land. We often think of the stars as ancient and unmoving, but our solar system is still young on a galactic scale. A newcomer in a city of older, more traveled suns. We are part of the galaxy's motion, but still early in its long, winding story. We have only seen a fraction of the galaxy's full rotation. The Milky Way's rotation defies Newton's predictions. According to Newtonian physics, stars farther from the galactic center should orbit more slowly, just as outer planets like Neptune move more leisurely around the Sun than Mercury does. But in the Milky Way, stars in the outer regions orbit almost as quickly as those near the center. This flat rotation curve defies classical expectations. It suggests there is more gravity pulling on them than we can see. The reason astronomers believe is dark matter, an invisible, unknown form of mass that surrounds the galaxy in a vast halo. Without dark matter, the galaxy would not hold together at these speeds. With it, the math works, The Milky Way turns like a solid wheel, not because we understand it fully, but because something unseen is holding it in place. The galaxy has enormous molecular clouds. Scattered throughout the Milky Way are vast dark clouds of cold gas, the raw material of stars. These molecular clouds, composed mostly of hydrogen molecules and traces of dust, can span hundreds of light years across. They are some of the coldest objects in the universe. Within their cold, dense interiors, gravity begins to gather material, forming clumps that collapse into new stars and planets. Some of these clouds are so large and so cold that they absorb visible light entirely, appearing as ink-black patches against the starry sky. They're the galaxy's wombs, quiet, hidden places where the future begins in silence, tucked within curtains of shadow and gas, waiting for the spark of gravity to light them up. Supernovae stir the galaxy like storms. When massive stars reach the end of their lives, they do not fade quietly. They explode in cataclysmic supernova events, so powerful they can outshine entire galaxies for a brief moment. But these explosions don't just end lives, they create. Shock waves from supernovae ripple through the interstellar medium, compressing nearby gas clouds and triggering new waves of star formation. They enrich the surrounding space with heavy elements like iron, nickel, and gold, forged in the heart of the dying star. In this way, supernovae act like storms within the galactic ecosystem, stirring, fertilizing, and reshaping everything around them. They're the galaxy's moments of chaos, destructive, radiant, and necessary. Without them, the universe would be a duller, simpler place. Dust hides vast regions of star formation. The Milky Way is full of light we cannot see. Interstellar dust, made of microscopic grains of carbon, silicates, and ice, weaves through the galaxy in dark clouds and tendrils. Invisible light, it obscures vast regions of space, blotting out stars and entire nebulae like a thick fog. But behind this veil, star formation continues. Using infrared telescopes, astronomers can peer through the dust, revealing glittering nurseries filled with newborn stars. What looks like darkness is often a cradle. The dust, though it hides, is part of the process, absorbing energy, helping gas cool, and shielding delicate stages of stellar birth. What seems like emptiness is often the beginning of something bright. There are starless gas clouds drifting through the galaxy. Not every cloud of gas becomes a star. Across the Milky Way, astronomers have found massive cold clouds that seem destined for collapse, yet remain dark and dormant. Some are too diffuse. Others may be stabilized by magnetic fields or internal turbulence. These starless clouds float through the galaxy like silent possibilities, rich in molecular hydrogen, but untouched by fusion. They may one day ignite, or they may drift until torn apart by external forces. Their gas recycled into other regions. In these clouds, the galaxy holds its breath, waiting, perhaps, for the right nudge to spark something new. The Milky Way recycles matter across generations. Stars are not permanent. They live, burn, and die. And in dying, they return their material to the galaxy. Supernovae spread heavy elements. Red giants shed outer layers. Planetary nebulae drift outward into space. This enriched material joins the interstellar medium, where it cools, condenses, and eventually forms new stars, planets, and even life. Every atom in your body has passed through this cycle, born in a star, scattered into space, gathered into new form. The Milky Way is not a static stage, but a great engine of renewal. It breathes in time with its stars, making, unmaking, and beginning again. The iron in your blood, the calcium in your bones, the oxygen in your lungs, all were once inside a star that died, so you could live. Metallicity holds clues to the early universe. In astronomy, metals are not just iron or gold. They are any elements heavier than helium. The earliest stars in the universe had almost none of these metals, because they formed before earlier generations of stars had a chance to forge and scatter them. Today, astronomers seek out metal-poor stars in the halo of the Milky Way. These stars, faint and ancient, preserve the chemical conditions of a time long gone. By analyzing their composition, we peer into the primordial past, into the period just after the Big Bang, before galaxies had matured, before the galaxy itself had taken full shape. They are fossils made of light, allowing us to touch the dawn of time. Some stars wander far from where they were born. A star's birthplace doesn't always define its destiny. Over time, many stars drift away from their natal clouds, pushed by gravitational interactions, orbital resonances, or the slow pull of spiral arms. Some stars are ejected at high speeds, flung across the disk or into the halo. Others migrate gradually, shifting their orbits inward or outward as they spiral through the galaxy. Even our sun is likely not where it began. Tracing the paths of stars reveals a Milky Way that is anything but static. A galaxy alive with movement, exchange, and quiet dislocation. Home for a star may only be temporary. The galaxy's habitable zone may span tens of thousands of light years. Just as Earth orbits in a Goldilocks zone around the Sun, not too hot or cold for life, the Milky Way may have its own galactic habitable zone. This region is thought to lie between the dangerous inner core, full of radiation and gravitational chaos, and the sparse, metal-poor outer edges where planets may be harder to form. Somewhere in between lies a wide band where conditions are stable. Star density is moderate, and elements like carbon, oxygen, and iron are abundant. Earth lies within this zone, one quiet orbit in a vast swirl where life might not be alone in finding a foothold. Perhaps there are other quiet worlds orbiting other quiet stars, wondering the same things we are. The spiral arms are not fixed structures. The Milky Way's spiral arms might seem like permanent features, grand sweeping lines carved into the galaxy's disk. But they are not made of fixed stars. Instead, they are patterns, density waves that ripple slowly through the disk, compressing gas and triggering new stars as they pass. Stars drift into these arms, shine for a while, and then drift out again. The spiral structure moves at a different speed than the stars themselves, like a traffic jam moving through a highway. From afar, it looks like form and order. From within, it's a pattern of shifting motion, held together by gravity and time. Never still, always flowing. The invisible energies, the Milky Way hums with cosmic radiation. Beyond visible light, the galaxy glows with more mysterious forms of energy. Cosmic rays, high-energy particles born in supernovae and distant galaxies, stream through space and pass through your body every second. X-rays and gamma rays shimmer from dying stars and black holes. Radio waves drift from gas clouds, pulsars, and the cold breath of hydrogen. These invisible hums reveal what light cannot. The violence, magnetism, and ancient fires still flickering within the galaxy's bones. When you look into the night sky, you're only seeing a narrow band of the Milky Way's true spectrum. Beneath the stars, the galaxy hums softly in many colors, many frequencies, a hidden symphony in the dark. There's a giant gamma ray bubble above and below the core, stretching tens of thousands of light years above and below the galactic center are two vast, ghostly lobes of high-energy light, the Fermi bubbles. Discovered only recently, they glow in gamma rays, extending like twin balloons from the Milky Way's heart. No one is entirely sure what caused them. They may be the remnants of a long-ago outburst from the central black hole, or the mark of fierce star formation that once flared through the core. Either way, these enormous structures drift silently over the galaxy. Invisible to human eyes, they are reminders that the Milky Way has a past we cannot fully see. Echoes of violence wrapped in radiance, far above the stars we know. We live in a minor spur between major arms. Our solar system doesn't lie in one of the Milky Way's grand spiral arms. Instead, we occupy a small structure called the Orion Spur, a relatively quiet lane of stars nestled between the larger Sagittarius and Perseus arms. It's not especially dense, nor especially active, but that may be why we're here. In the calm between galactic highways, massive supernovae, radiation storms are less frequent. This quiet corner may have given life on Earth the time it needed to emerge and evolve. From the outskirts, the galaxy seems dramatic and radiant. But in this quiet spur, we found just enough peace for complexity to unfold. A safe harbor in a restless sea. The Milky Way has a bar-shaped center. When astronomers look toward the galactic core in infrared light, they see not a perfect circle, but a thick, elongated bar of stars crossing the middle. A kind of glowing bridge. This bar rotates slowly, and its gravitational pull shapes the inner spiral arms. Bars like this are common in spiral galaxies. They form when stars in the disk begin to drift inward and pile up along a central axis. Over time, the bar becomes a stable structure. Stirring gas, triggering new stars and feeding material toward the black hole at the center. It is not just a shape, but a dynamic engine sculpting the galaxy's heart from within. It's part of a larger structure called the local group. The Milky Way doesn't exist in isolation. It belongs to a collection of more than 50 galaxies known as the local group, a small cluster drifting together through space. The two largest members are the Milky Way and Andromeda, each with its own family of satellite galaxies. Scattered around them are smaller dwarfs, faint ellipticals, and starless galaxies made almost entirely of dark matter. The local group spans more than 10 million light years, and it is bound together not by proximity alone, but by gravity. We are part of the family, quiet, widely spaced, but still linked by the invisible threads of shared motion and mutual pull. Galaxies in the local group are gravitationally bound. Despite their vast separations, the galaxies of the local group are not drifting apart. In fact, many are moving slowly toward one another. Gravity holds them in a kind of slow-motion ballet, curving their paths across millions of years. Some of the smallest galaxies orbit the Milky Way like moons, looping and falling, dissolving into streams. Others drift independently, but remain tethered, caught in a web of shared motion. Over time, this group may condense. Galaxies may merge, fade, or be absorbed. It's not a static arrangement, but a gentle gathering of cosmic islands. A family drawn closer by time, inertia, and the long reach of gravity. The galaxy's disk has a thick and thin component. The Milky Way's disk looks flat from a distance, but up close it's layered. The thin disk is where we live. A wide, dense plain filled with young stars, open clusters, and star-forming gas. But above and below it lies the thick disk, older, puffier, and more diffuse. Stars in the thick disk tend to be older with fewer heavy elements. They move in orbits that are more tilted and elliptical, suggesting they formed under different conditions or were stirred by early galactic collisions. The galaxy's disk is not uniform. It's textured, layered, and shaped by time, like sediments settled on the floor of a cosmic ocean. The galaxy's magnetic field threads through the disk. Though invisible to the eye, the Milky Way is laced with a vast magnetic field, stretching across the disk, rising into the halo, and weaving through the interstellar medium. This field is weak by earthly standards, but over galactic distances, it shapes how cosmic rays travel, how gas clouds collapse, and how matter flows through space. It aligns with spiral arms, forms arcs above the plane, and twists into loops that defy simple explanation. Studying it requires radio telescopes and careful analysis, but its presence is unmistakable. The Milky Way does not just glow with light. It breathes with magnetism, a subtle pulse running through its bones. The interstellar medium is full of invisible structures. Between the stars lies more than emptiness. The interstellar medium, a thin blend of gas, dust, and plasma weaves its way through the Milky Way like a fog. To the naked eye, it is mostly invisible, but when viewed with radio and infrared telescopes, it reveals a stunning complexity. It forms filaments, bubbles, shock waves, and cold, dense clouds where stars are born. Supernovae carve vast cavities in it, stellar winds sculpted into shapes that ripple across light years. The space between stars is not a void, but a shifting web of matter and magnetism, the quiet fabric from which galaxies evolve and life eventually begins. Cosmic rays constantly pass through us from the galaxy. Every second, high-energy particles, mostly protons and atomic nuclei, stream through your body, launched long ago by exploding stars. These are cosmic rays, and they are everywhere. They travel close to the speed of light, bending through magnetic fields, bouncing off clouds, and occasionally colliding with atoms in Earth's atmosphere, where they create showers of secondary particles. Most of the time, we don't notice them, but they carry stories from across the galaxy, evidence of ancient supernovae, traces of distant acceleration, messages from the violent hearts of stars. Even as you rest, the galaxy is whispering in particles, in silence, in lightless rays. The galaxy is not symmetrical, though many diagrams show it as a neat, even spiral. The Milky Way is not perfectly balanced. One side of the disk appears thicker. Some spiral arms are brighter, longer, or more curved than others. The warp in the outer disk is lopsided. Even the star counts between hemispheres are slightly off. These asymmetries may be caused by gravitational encounters, past mergers, or the influence of dark matter. They remind us that galaxies, like living things, carry traces of their histories in their shapes, scars of collisions, wrinkles of time, and quirks of uneven growth that give them character and depth. Star's solar system, the oldest known star, may live in our halo. High above the galactic plane, drifting through the halo, astronomers discovered a star that may be nearly as old as the universe itself. It contains almost no heavy elements, a signature of stars born soon after the Big Bang, before generations of supernovae enriched the cosmos. It likely formed over 13 billion years ago, long before the Milky Way was fully formed. It burns quietly now with a soft red glow, low in mass, but rich in history. It is not just a star. It is a time capsule, a living relic from the universe's earliest dawn. The center of the galaxy spins faster than the outskirts. In the inner regions of the Milky Way, stars orbit the center much more rapidly than those farther out. Near the core, the gravitational pull is stronger, packed with mass from stars, dust, and the supermassive black hole, Sagittarius A star. This causes stars to sweep through tighter, faster orbits, completing revolutions in just a few million years. Out in the suburbs of the galaxy, like where our sun lives, stars orbit more slowly, taking hundreds of millions of years. This uneven rotation creates twisting patterns, stretches spiral arms, and keeps the disk from behaving like a solid structure. The galaxy moves like a great wheel, but one whose rim lags behind its core. Stars are born from cold, collapsing gas. In the dark arms of the Milky Way, star formation begins in silence. Massive clouds of molecular hydrogen, sometimes hundreds of light years wide, drift through space, chilled to just a few degrees above absolute zero. Within these clouds, gravity slowly takes hold. Small regions grow denser and begin to collapse under their own weight. As the gas falls inward, it heats, spins, and flattens, forming a protostar at the center. Over time, the pressure and temperature grow until nuclear fusion ignites, and a new star is born. From the coldest shadows come the brightest lights, spun gently into being by the quiet force of gravity. Star clusters can dissolve into the galactic field. Many stars are born not in isolation, but in groups. Stellar clusters shaped from the same collapsing cloud of gas and dust. Our sun was almost certainly one of these. Long ago, it shared space with hundreds, perhaps thousands, of sibling stars, all born in the same cradle. Over time, gravitational tides, passing stars, and the motion of the galaxy scattered the cluster. Most of the sun's siblings have wandered far, flung into different orbits, carrying with them fragments of our shared past. Some may still shine nearby, invisible among the stars, lost family in a sea of light. The sun's siblings are scattered across the galaxy. Though the sun's birth cluster has long since dissolved, astronomers are searching for its lost siblings, stars that share its age, motion, and chemical fingerprint. Using vast surveys like Gaia and spectroscopic databases, researchers hope to identify these long-lost relatives. A few candidates have emerged, stars that may have shared our origin, formed from the same cloud of enriched gas. If found, they could reveal details about the conditions in which the sun and the early solar system were born. Our place in the galaxy is not entirely solitary. Somewhere out there, the sun's ancient kin may still shine. The galactic disk wobbles as it spins. The Milky Way's disk is not perfectly flat. It wobbles, gently rippling like a spinning plate nudged off balance. This warp is most visible in the outer regions, where the disk bends upward on one side and downward on the other. It may be caused by the gravitational influence of nearby dwarf galaxies, interactions with dark matter, or internal asymmetries. The wobble rotates slowly, like a vast wave moving through the stars. From Earth we don't feel it, but from afar, the Milky Way is not a pristine spiral. It is a breathing, undulating sheet of stars, curving gently as it turns. Galactic tides can distort star clusters and streams. Just as the moon's gravity pulls tides on Earth, the immense mass of the Milky Way exerts tidal forces on everything within it. Star clusters, satellite galaxies, and even globular groups feel the galaxy's uneven gravitational pull. Over time, these tides can stretch and distort them, drawing out long stellar streams or peeling stars away from their orbits. Many of the faint arcs of stars mapped across the sky are remnants of such encounters, clusters in the process of being unraveled, galaxies slowly torn apart. The galaxy doesn't break these structures suddenly. It unravels them patiently, strand by strand, over millions of years. The Milky Way's mass is still uncertain. You might think we would know the mass of our own galaxy, but measuring it is remarkably difficult. Stars and gas make up only a small portion of the total. The rest lies in the vast dark matter halo, which we cannot see directly. Estimates vary. Some suggest a mass close to 1 trillion times that of the Sun. Others place it much higher. The uncertainty comes from trying to measure how fast stars orbit at great distances, a task clouded by limited data and the influence of invisible matter. The Milky Way is our home, but its weight remains a quiet mystery. It may be heavier than Andromeda. For many years, astronomers assumed that the Andromeda galaxy, slightly larger and brighter than the Milky Way, was also more massive. But recent measurements suggest that the Milky Way's dark matter halo may be broader and denser than previously believed. If that's true, our galaxy could outweigh Andromeda, despite its more modest appearance. This matters not only for comparisons, but for predictions. When the two galaxies eventually merge, their relative masses will shape the encounter's dynamics. The Milky Way may look gentle, but beneath its quiet spiral arms, it carries more weight than we once imagined. The Magellanic Clouds may be on their first orbit. The Large and Small Magellanic Clouds, two bright satellite galaxies visible from the southern hemisphere, have long been thought to orbit the Milky Way. But new evidence suggests they may be newcomers, captured only recently in cosmic terms. Their velocity and motion through space hint that this could be their first close pass. If true, they're not long-standing companions, but distant wanderers just now falling under the Milky Way's pull. Their arrival has stirred the outer disk and warped the galaxy's shape, as if the Milky Way is responding to a new gravitational guest. The sky's quiet is full of first encounters. The Magellanic Stream is a ribbon of stripped gas. Trailing behind the Magellanic Clouds is a vast ribbon of hydrogen gas, the Magellanic Stream. It stretches over hundreds of thousands of light years, wrapped in curves and arcs across the southern sky. This stream was pulled away by tidal forces as the dwarf galaxies pass close to one another into the Milky Way. Invisible in visible light, it reveals itself in radio wavelengths. A long, trailing whisper of motion and loss. The stream may one day feed new star formation in the Milky Way, or settle into the halo like a thread of memory stretching between galaxies. Some gas clouds orbit in polar directions. Not everything in the Milky Way follows the neat plane of the disk. Some clouds of gas, and even some stars, move in highly inclined orbits, passing above and below the galaxy's main structure. These polar orbits likely come from past mergers. when dwarf galaxies or stray clouds were captured at odd angles. Over time, they continued to orbit on tilted paths, like comets around a planet. These misaligned orbits are records of disruption, visible reminders that the galaxy is not a closed system, but an evolving structure shaped by the unpredictable flow of cosmic history. Giant shells of gas surround past starbursts. In several regions of the Milky Way, astronomers have found enormous spherical shells of gas, some spanning hundreds of light years. These shells are the remnants of powerful starbursts, episodes when clusters of massive stars formed together, lived brief lives, and exploded in rapid succession. Their combined winds and supernovae carved out huge cavities in the interstellar medium, blowing gas outward in all directions. Over time, the expansion slows, but the shells remain, ghostly bubbles marking where the galaxy once burned bright with stellar birth and death. These are the fossils of cosmic fireworks, still echoing in the cold. Stars occasionally collide in dense regions. Space is vast and stars are small. But in the densest regions of the Milky Way, such as the cores of globular clusters, stars can pass close enough to interact and even collide. When they do, the result could be dramatic. A burst of light, the merging of two suns, or the formation of a rare blue straggler star, one that appears younger than its neighbors. These collisions are rare, but not impossible. Over billions of years, the tightest stellar neighborhoods can rearrange themselves through gravity and chance. In these crowded stellar cities, time moves differently, and space is never quite empty. Binary stars can be torn apart by tidal forces. Many stars live in pairs, orbiting each other in gravitational embrace. But even this bond can be broken. If a binary system passes close to the Milky Way's central black hole, or through a dense cluster, tidal forces can disrupt their orbit, flinging one star away while the other is captured or slowed. In some cases, a companion is hurled out of the galaxy entirely, becoming a rogue star speeding through intergalactic space. These stellar breakups happen silently in places we rarely see. A quiet tearing of ancient partnerships by gravity's invisible hands. Some stars escape the galaxy entirely. Most stars are gravitationally bound to the Milky Way, but occasionally a star reaches escape velocity, over 500 kilometers per second, and is flung outward, never to return. These hypervelocity stars are rare but real. Some are thought to be ejected by interactions with the supermassive black hole at the galaxy's center. Others may be slingshot by three-body encounters or supernovae in binary systems. Once free, they travel alone into intergalactic space. Tiny lighthouses drifting far beyond the spiral's edge. They carry the galaxy's memory outward, becoming solitary pilgrims in the great dark between galaxies. The Milky Way contains stars from other galaxies. Not all stars within the Milky Way were born here. Some may have originated in other galaxies, captured during mergers or flung into our halo from distant regions of the local group. These intergalactic wanderers often move on unusual orbits far from the disk, tracing paths through the outskirts or halo. They can be identified by their composition or motion. Stars that don't quite fit the local patterns. Like cosmic immigrants, they bring stories from other environments, other histories, other skies. The Milky Way is not a sealed system. It is a living mosaic, slowly stitched together by time and motion. Gas cycles like a fountain between the disk and halo, above and below the Milky Way's bright disk. Gas rises and falls in a quiet loop known as the galactic fountain. Supernovae and stellar winds heat and eject material upward into the halo, where it cools, condenses, and gently rains back down over millions of years. This cycle stirs the interstellar medium, redistributes heavy elements, and helps regulate star formation. It's a quiet respiration, a breathing motion of matter between the dense plane and the vast halo. The galaxy, in this way, doesn't just spin, it circulates. It exhales and inhales, keeping its structure in motion across immense spans of time. The galaxy's dust grains carry organic compounds. Within the clouds of interstellar dust that drift between stars, scientists have detected complex organic molecules, carbon-based compounds that form the raw ingredients for life. These include polycyclic aromatic hydrocarbons, simple sugars, alcohols, and more. Though not alive, they are chemically rich, formed in the atmospheres of dying stars or within cold clouds shaped by radiation. These tiny grains, carried across light years by galactic winds, settle into the gas that forms stars and planets. Some may have fallen onto the early Earth. The galaxy's dust is not just debris. It is a cargo of potential, drifting silently through the dark. Interstellar clouds may seed solar systems with ingredients for life. The birthplaces of stars are also the birthplaces of worlds. As planetary systems form from collapsing clouds of gas and dust, they inherit the chemical fingerprints of their parent nebulae. If that cloud contains water, carbon compounds, and other building blocks of biology, those ingredients may end up in comets, asteroids, or planets. Some regions of the Milky Way are especially rich in such prebiotic chemistry. We don't yet know how common life is, but the conditions for it seem to arise naturally. The seeds of life may be scattered far and wide, tucked into the galaxy's coldest cradles, waiting for a place to grow. Some stars rotate hundreds of times faster than the sun. Most stars spin, but some spin incredibly fast, completing a full rotation in just a few hours. These rapid rotators are often young, massive, and unstable, with equators that bulge from centrifugal force. A few reach such high speeds that they fling off material, forming glowing disks around themselves. The sun rotates once every 25 to 35 days, depending on latitude. But these fast-spinning stars rotate hundreds of times more quickly, approaching physical limits. Their internal structures, and evolutionary paths are different. Their lives may be brief, but while they last, they spin like sirens in the dark. The galaxy is tilted relative to the ecliptic. From Earth, the Milky Way arcs across the night sky in a graceful band of light, but it doesn't align with the plane of our solar system. The galactic plane, the flat disk in which most of the galaxy's stars reside, is tilted about 60 degrees relative to the ecliptic, the path traced by the sun and planets. This tilt is why the Milky Way rises at an angle, and why it shifts position with the seasons. We are part of the galaxy, but our own little system is angled slightly askew. A small, tilted boat drifting through a larger, spinning sea of stars. Some stellar remnants are older than the galaxy's disk. Among the faint stars in the halo, astronomers have found white dwarfs, the cooling cores of once luminous stars that are older than the Milky Way's thin disk itself. These ancient remnants formed when the galaxy was young, before its main structure had fully settled. Their existence hints at an earlier time of star formation, a deeper history etched into the outer halo. They have burned for billions of years, slowly fading, carrying with them the quiet residue of a time when the Milky Way was still gathering its shape. The disk may be bright, but the halo remembers further back. The farthest stars orbit well beyond the main structure. The Milky Way's most distant stars orbit far beyond the familiar spiral arms, tens or even hundreds of thousands of light years from the center. These stars move through the galactic halo on slow, wide paths, taking billions of years to complete a single orbit. Many were likely captured from smaller galaxies in past mergers, now drifting in the outermost reaches like distant sentinels. They are faint, sparse, and far between, but they help define the galaxy's size, shape, and gravitational influence. The Milky Way is not just what we see. It extends deep into the dark, shaped by wanderers at its edge. We see the Milky Way edge on from Earth. Because we live within it, we cannot look down on the Milky Way from above. Instead, we see it from the inside, a flat ribbon of stars stretching across the sky, curved only by the horizon. This edge-on view compresses the galaxy into a single arc, making it hard to grasp its full structure from our perspective. It took centuries of observation, cataloging, and mathematical deduction to realize the spiral we belong to. From Earth, we gaze through its disk, like standing in a forest and looking along the line of the trees. We do not see the shape we're part of, only the vastness that surrounds us. The galaxy holds far more than we can ever possibly see. Even with our most sensitive instruments, we glimpse only a fraction of what the Milky Way contains. Light is blocked by dust. Motion is hidden in silence. Dark matter outnumbers luminous stars. Between every star lies emptiness, and within every empty space, potential. The Milky Way is not just what we see. It is what we suspect, what we infer, what we long to understand. It holds ancient light, future stars, drifting worlds, and questions still without answers. And within that vastness, somehow, we find ourselves, one planet among many, orbiting a quiet star, floating through a story too wide for the eye. Conclusion: the return to sleep, and now, the stars begin to dim behind your thoughts. We've drifted through 100 quiet truths, from the warp of the galaxy's disk to the farthest halo stars, from newborn suns to long-dead remnants, from dust and gas to light and shadow, and everything in between. You've wandered through stellar nurseries, danced along spiral arms, and gazed toward the galactic heart glowing behind curtains of dust. You're a part of this galaxy, not just a passenger on Earth, but a participant in its long and luminous unfolding. The iron in your blood was forged in stars. The oxygen you breathe was sculpted in ancient explosions. The atoms of your body trace their lineage to the earliest times, born from the same matter that now fuels suns and whispers through clouds of interstellar dust. Tonight, as you rest, the galaxy turns on. Stars are forming. Light is traveling. Silent orbits continue, and you're floating within it, a small warmth in the dark, resting in the spiral arm of a quiet, radiant sea. If you happen to still be awake, you can go ahead and watch the next chapter now. I hope you sleep well and dream softly. Good night.